Matematika. Today we're going to do part 3 of equivalent representation of polynomial and rational expression, and that is the remainder and factor theorems. When dividing p of x by a linear divisor x plus or minus a, where a is a constant, we write it as p of x divided by x minus a, and that is q of x plus r of x over x minus a. This is the notation of the result when you divide a polynomial divided by a linear divisor. So to check the answer, if we found the quotient and the remainder, we multiply the quotient by the divisor and added the remainder. So that is to check. We want to check the answer. So to check, we are going to multiply the remainder by the quotient. So if our quotient is q of x, and then multiplied it by the divisor, which is x minus a, and then add the remainder. Okay, we have some kind of notation right here. So suppose you are given that x is equals to a, and the remainder is a constant r. Okay, r is the remainder. If we substitute this into the equation right here, which is q of x times x minus a plus r times x. So we have the p of a would be equals to q of a, then times x minus a, so we replace x with a, plus r of x, we replace the r of x with r. Alright, so what is going to happen here, q of a minus a, that is 0, plus r, q of a times 0 is 0 plus r, then the p of a is equals to the remainder. Okay, that's equals to the remainder. So this result shows that we can find the remainder of p of x divided by x minus a without performing the division or without dividing it. Either it's a long division or synthetic division, r can be found. The remainder can be found by using the remainder theorem. So the remainder theorem can find the remainder of p of x divided by x minus a without performing the division. So the remainder theorem can be extended to the factor theorem, which can help us find the factors of polynomial without fully factoring the expression. So what is a remainder theorem? For a polynomial of p of x and a number a, the remainder on division by x minus a is p of a. Okay? So it says that the remainder can be extended to the factor theorem. Say if you were able to have or to get the remainder, and then maybe you can get to know if that divisor is a factor by using the factor theorem. So what is a factor theorem? For a polynomial of p of x an a, the number a, x minus a is a factor of p of x if and only if p of a is equals to 0. And that's the one we are going to find out. Let's have example 1. Using the remainder theorem, we used to hold on. Using the remainder theorem, determine the remainder when the p of x 2x cubed minus 4x squared plus 3x minus 1 is divided by 2x plus 1. Okay? So let's do this. So what do we do with the remainder theorem? So we need to substitute the value of x that makes 2x plus 1 equals to 0. So in other words, 2x plus 1, we have to equate that to 0. So 2x would be equals to negative 1. So x is negative 1/2. Remember that by finding the remainder, we don't need to use long division or synthetic division, but we're going to use the remainder theorem. Okay? So by the remainder theorem, we can use the p of x now. P of negative 1/2 is the remainder when p of x is divided by 2x plus 1. Okay, p of negative 1/2 is the remainder. When p of x, that is 2x cubed minus 4x squared plus 3x minus 1 divided by 2x plus 1. Okay? I'm not writing it as this, okay? But when I say p of x, that is what I mean as 2x cubed minus 4x squared plus 3x minus 1. Then, what we're going to do is to substitute. Since our p of negative 1/2, we substitute it to the polynomial. So that would be 2 times negative 1/2 cubed minus 4 times negative 1/2 squared plus 3 times negative 1/2 minus 1. Okay, let's simplify. Let's evaluate the exponents first. So that would be 2 times 3 negative is negative. And 2 to the third power, that is 8. So that would be negative 1/8 minus 4. 2 negative, that would be positive. So 2 squared is 4. So that will become 1/4 plus 3 times negative 1/2. That is, okay, that's 3. I'm going to write this as, alright, I go directly as negative 3/2. Okay, then minus 1. Alright, we multiply now. Negative 2 times negative 1, that's negative 2/8. Then we have negative 4/4 minus 3/2 minus 1. Let's simplify more. 2/8 is negative 1/4. Negative 4 over 4, that's 1. Minus 3 over 2, minus 1. Okay. I think I'm going to... Alright, there are several ways of simplifying this. I want everything to be in... how do you call this? By having a least common denominator. I could say that. Negative 1 and negative 1, I could combine that. Negative 3 over 2, then minus 2. Since our denominator here is 4, the greater than 2, so might as well I put everything under the denominator of 4. 4 by 4, it's 1. 4 divided by 2, it's 2 times negative 3, that's negative 6, right? Then 4 divided by 1 is 4. Then times 2, that's negative 8. Okay? So I have negative 1, negative 6, negative 8, that's negative 15 over 4. Alright. When P is divided by, we found our remainder. So we say when P of X is divided by 2x plus 1, the remainder is negative 15 over 4. That's it. Without using a long division. So you can find the remainder by getting and equate the divisor to 0 and get the value of x. After that, replace that value to the polynomial, and then you will get the remainder. Now, the second part of it is telling us if P of A is equals to 0, then x minus A is a factor. From that, we can determine that we can determine that P of A, you can see it like this. We can determine that P of A is equals to 0, then x minus A is a factor. From that, we can also determine that if P of A is not equals to 0, then x minus A is not a factor. This time we are talking about the factor of P of X. Okay? Let's find out if our divisor is a factor of the polynomial given, or it's not a factor of the polynomial. All right, let's do this. When the polynomials P of X equals x to the fourth plus 5x cubed minus mx plus n, and Q of X is equals to mx squared plus nx minus 1, are each divided by d of x. Okay, this might be our divisor. The remainders are 7 and negative 6 respectively. Find the values of m and m. So the remainders are given. So might as well we can use the remainder theorem that our divisor is x minus 1. That means the x is, if we equate that to 0, that means the x is equals to 1. Then we could say that the p of 1 factor is 7, and the other factor, the q of 1, is negative 6. That's the one we are going to create two equations to solve, whereas the m and the n, that's the problem. We're going to find the m and the n. Okay, by replacing, okay, I'm gonna start with piece of 1, okay, which is 7. So if we replace that to this polynomial, okay, so I would say piece of 1 equals x to the 4th plus 5x to the 3rd minus mx plus n. So piece of 1 is 7. I will replace 1 to the 4th power, 5 times 1 to the 3rd, m times 1 plus n. Okay, so this will be 7. 1 to the 4th is 1. 5 times 1 is 5. M times 1 is m plus n. Okay, so let's simplify. 7 equals 6 minus m plus n. I would like to bring this m minus n, the variable, to the left side and making it into a positive. Okay, so this will become, since I put a parenthesis here, I could do it this way, so to avoid confusion. So I would bring the negative m to the left, so this will be a positive n, and then bring the positive n to the left, and that would be a negative n. Then 7 is equals to 6. Okay, so I will transpose 7. That would be 6 minus 7. M minus n equals negative 1. Or we could say negative m plus n equals positive 1. All right, we can make that as the equation. So let's do the other one. Q sub 1 is 6. So I will, the Q sub 1 is Q of x is given, right? That is mx squared plus nx minus 1. Okay, I'm gonna replace the q's of 1 equals negative 6. So this is negative 6. So I have negative 6. Then I replace the x with 1, because this is q's of 1. I've got to replace, sorry, that. Q's of negative 6. So I could say negative 6 and replace the x with 1 plus n times 1 minus 1. So negative 6, m times 1 squared is m plus n minus 1. So add 1 to the left. This will be a negative 5 equals m plus n. And that would be the second equation. So we have two equations. Our target is to find the value of m and n. So we could use the systems of equations. I could have this equation. I make that as equation 1 and this is equation 2. And then combine m plus n equals 1. And I could have m plus n equals negative 5. Okay. So I could cancel this out. I have 2n equals, this is negative 5. It's not that clear. That would be negative 4. So n is negative 4 divided by 2. That is negative 2. We have the value of n. So once we know the value of n, we could have the value of m. Say m plus n equals negative 5. So n is negative or plus m plus negative 2 equals negative 5. So m is negative 5 plus 2. M is negative 3. Okay, you have now the value of m and n. And you can verify it by checking and substituting the value of m and n, and you can check that. Let's have 3. Use the factor theorem to determine the divisor if the divisor is a factor or... Okay, let's do this. Use the factor theorem to determine if the divisor is a factor of the dividend in the expression. Okay, so we are going to determine if it's a factor, this time using the factor theorem. Okay, so what we're gonna do here is we let our p of x as our polynomial 2x cubed plus x squared minus 10x. And by using the factor theorem, if x minus 2 is a factor of the p of x, so we'll get the x minus 2. We equate that to 0 first to get the value of x, and we could have the p of 2 would equals to 0. That is f. Then that is the x minus 2 is a factor. We want to find out if p of 2 is equals to 0. Okay, let's do this. We'll substitute the p of 2 to the polynomial by having it as 2 times 2x 2 to the third power plus 2 to the second power minus 10 times 2 over, oh, sorry. I was just checking on this. All right, I'm checking on the polynomials. Okay, let's go ahead. 2 cubed is 8. 2 squared is 4. 10 times 2, that's 20. So 16 plus 4 minus 20, that's equals to 0. That means the piece of 2 is equals to 0. Since P of 2 equals 0, then, okay, since piece of 2 equals 0, then we could say that the x minus 2 is a factor of 2 x to the third plus x squared minus 10x. And that is how you're going to use to find out if it's a factor. Now we can use this information to fully factor the expression. Since the divisor is x minus a, we can use the synthetic division since our divisor is a linear. So what would be using the synthetic? We put the divisor table upside down. So 2 is the coefficient here. Then 1. Then we have negative 10 and 0 for the constant. And our divisor is 2. Okay, bring down 2. 2 times 2, it's 4. 1 plus 4, it's 5. 5 times 2, it's 10. 10 minus 10 is 0. 0 minus 0 plus 0 is 0. So the result of the synthetic is 2x, one degree lower. So that would be 2x to the second power plus 5x. Okay, so we can rewrite that the factor of p of x is equals to, what's the other factor that we have? X minus 2 is one factor, because we say x minus 2 is a factor. And one factor is 2x squared plus 5x. But we can still, having a common factor of 2x squared equals 2x squared plus 5x. We can still factor that out by having x as a common factor. Right, I will pull that x out. So I have 2x plus 5. Okay, so all in all, our factors are simplified. One factor is x, the other one is x minus 2, and the other one is 2x plus 5. So these are the factors. Okay, these are the factors if you will be asked. But this answer the question if the divisor is a factor of the dividend. All you have to do is to check if it's equal to 0, then it's a factor. But if it is not, then it's not a factor. When you equate the p of x to the polynomial. Okay, let's have another one. Given x plus 4 is a factor of p of x 6x cubed plus 31x squared plus 25x minus 12. Find the remaining factors and rewrite p of x as a product of the linear factors. So we have have shown using the factor theorem in question number 3 to find out whether 1 is a factor or not. Okay, so we're gonna check x plus 4 is a factor of p of x. It says here x plus 4 is a factor. So since we already know that x plus 4 is a factor of p of x, then we can divide p of x by x plus 4 and factor the resulting quadratic expression. I know we can have a quadratic because we have an x to the third power. Okay. Since our divisor is linear, might as well we can just simply use the synthetic division. So we'll have the division table upside down. And finding our divisor, x plus 4 equals 0. So x is negative 4. So our divisor here is negative 4. I'm going to write. I'm checking if everything is in order. Okay. So the first coefficient is 6. Then we have 31. Then 25. Then negative 12, our constant. Okay, bring down 6. 6 times negative 4, that's negative 24. 31 plus negative 24, that's 7. 7 times negative 4, that's negative 28. 25 plus negative 28, that's negative 3. Negative 4 times 3, that is positive 12. Okay, that's positive 12. Plus negative 12, that is 0. So the result is 6. Okay, we're going to write. Since our degree here is 3, 1 less degree, that would be 6x squared plus 7x minus 3. This is the quotient. Now we can factor the trinomial. Okay, we can factor this by looking at 6 times 3 to get our factor. That's negative 18. What would be our factor in such a way that we come up with the middle term as 7? 2 and 9. Okay? So one factor could be 2 and 9. So 2 is negative and 9 is positive since our middle is positive. So the higher number will get a positive value. So then we're going to write them in the form of, in order to factor them out, then we're going to write this in form of a grouping. We can write this as 6x squared. What's the result of 7x? Is negative 2x plus 9x, right? Then minus 3, right? So we have regrouped that 6x like this. What's common? 2 and x, right? 6x squared divided by 2x, that is 3x. 2x minus 2 divided by 2x, that's negative 1. And then common factor here in 9x minus 3 is 3. Then 9x divided by 3, that is 3x minus 1. We come up with a common factor of 3x minus 1. then our factor is, here is 3x minus 1, and the coefficient, put them together as one factor. So the remaining, these are the factors of p of x, right? Is x plus 4, which is already the factor, and then 3x minus 1 and 2x plus 3. So you have 3 factors out there as a factor. Alright, let's summarize. To find the remainder of p of x over x minus a without performing division, we can evaluate p of a, and the result will be the remainder. And we can use the factor theorem to determine if a linear factor x minus a, is a factor of polynomial p of x by determining if p of a is equals to 0. If it's equals to 0, then that divisor, okay, that linear factor is a factor of p of x. Okay? So let me say this. If I can do it, so can you. Don't forget to hit the like button and press the subscribe button if you haven't subscribed yet. See you in my next video.